If you have spent any time around software or tech conversations lately, you have probably noticed the phrase AI agents showing up everywhere. They are often described as autonomous workers, digital teammates that can plan, reason, and execute tasks on their own. It sounds impressive, and it's easy to see why people get excited about it. At the same time, that framing tends to make the idea feel more mysterious and more powerful than it really is. So, in this video, I want to slow things down a bit. No hype, no fear, no claims about replacing developers, just a clear, grounded explanation of what AI agents actually are, how they work in practice, and when they are genuinely useful in real software projects. At the simplest level, an AI agent is software that looks at its current situation, decides what to do next, takes an action, and then repeats the process. Somewhere inside that loop, a language model is used to help with the decision making. And by language model, I'm referring to OpenAI, Google, Facebook, Llama, etc. That detail matters because the agent itself isn't the model. The agent is the system you build around the model. This is where a lot of the confusion starts. When people hear agent, they often imagine something that thinks independently, almost like a person. But agents don't have goals on their own. They don't understand the intent of the user, and they don't know when they are wrong unless you give them a way to check it. Every bit of autonomy they have comes from instructions, constraints, and a structure that a developer put there on purpose. That's why a lot of the common hype falls apart pretty quickly. Agents aren't autonomous workers, they don't reason like humans, and more autonomy doesn't automatically mean more value. In practice, giving an agent too much freedom usually just creates more edge cases, more failure modes, and more debugging work. What people call intelligence is often just consistent behavior emerging from a carefully controlled loop. If you break an agent into parts or components, it becomes much easier to reason about. There is the state, which is everything the agent knows right now, the inputs, the context, the memory, and past results. There is decision logic, which might be a prompt, a set of rules, or a planner that decides the next step. There are actions, which are the concrete things like calling an API, reading or writing data, querying a database, sending a message. Then there is the feedback, where the result of an action updates the state. And finally, there are constraints like time limits, budget, permissions, and clear stopping conditions. In most real systems, this last part is where reliability actually lives. One idea that's useful here is that agents are really about control, not the capability. Most of the work is deciding what the agent is allowed to see, what it is allowed to touch, and when it must stop. The model may generate the next step, but the system is the one who decides whether that step is even possible or not. When agents fail in surprising ways, it's usually because that control layer was thin, rushed, or not actually carefully planned. Another helpful way to think about agents is to compare them to workflows that you already know. In many cases, an agent is just a workflow that can choose its next step dynamically instead of following a fixed sequence. That flexibility can be powerful, but it also means you lose some predictability. Knowing when you want flexibility versus when you want certainty is an important decision. It's an important decision, not an implementation detail per se. Having said that, there are places where agents work very well. They are a good fit for long-running, multi-step tasks when you don't know the entire path up front and where partial progress still has some value. Things like scanning a large codebase to build understanding across many files, for example Cursor, doing background research and refining summaries over time. Also, building internal tools that prepare drafts or surface options before a human steps in. In these cases, the agent supports the work rather than trying to replace the judgment. They also work best when failure is acceptable and visible. If an agent produces a rough draft, you can fix it. If it misses something, you can just rerun it. The cost of being wrong is relatively low, and that makes the iteration safe. Once the cost of failure goes up, then the design needs to become much more conservative. A useful extension of this idea is to think about reversibility. Agents are much safer in systems where actions can be undone or reviewed. Drafting, labeling, summarizing, and suggesting are all reversible. Directly mutating critical data? It is not. This simple distinction can save a lot of trouble when deciding how far an agent should be allowed to go. A lot of problems show up when agents are used in the wrong places. Unclear goals are a big one, for example. If the agent doesn't know what done means, it may stop too early, continue going on endlessly, or take actions that you didn't even intend to do. Missing the stopping conditions, like giving too much freedom too soon or poor observability, makes systems harder to trust. One very common mistake is replacing simple deterministic logic with an agent when a clear rule of a script could have been enough. For example, an if-else. Another subtle misuse is expecting agents to clean up unclear requirements. If humans don't agree on what the system should do, an agent won't magically resolve that ambiguity. In fact, it will usually amplify it. Agents tend to expose weak specifications rather than hide them. A few mental models help things grounded. For example, one is to think of an agent as a loop with guardrails. If you remove the guardrails, you don't get intelligence, you just get some unpredictable behavior. Another model is to start agents in read-only mode, letting them observe and suggest before they are even allowed to act over something. And as a rule of thumb, if you can explain that the agent is doing in plain language, then the system is probably too complex for its own good. It's also helpful to think in terms of multiple layers. A stable system often has some deterministic code at its core, and there are agents along the lines sitting at the edges doing extra work. The core is the one that enforces the variability. The agent handles the ambiguity. Mixing those layers too freely tends to create fragile designs. For freelancers and solo developers specifically, it helps to reframe what agents are actually good at. They don't really reduce thinking, but they can reduce coordination cost. They prepare the work, they connect systems, and they handle the glue between the tools. That's where the real productivity gain tend to come from, not from handling over decision making, but from clearing the mental space and reducing the context switching, which is a really big problem in this area, let's say. Over time, this leads to a healthier relationship with the tools. Instead of asking, can an agent do this for me? The better question might be, where would flexibility help and where do I need the certainty? That question applies to agents, automation, and system design in general. Seen this way, AI agents aren't magic, not at all. They are an automation that can adapt within boundaries you define. They sit somewhere between a script and a human, and they work best when that middle ground is respected. If you treat them like coworkers, you will likely be disappointed if you give them too much freedom. If you treat them like systems designed, constrained, and observable, then it will be genuinely useful. That mindset extends beyond the agents. It not just due to we're building software that's simpler, more reliable, and easier to reason about. Over time, focusing on clarity, constraints, and reversibility tends to reduce unnecessary complex. And for most long-lived systems, that quiet reliability ends up being far more valuable than chasing the newest abstraction. Thanks for joining.